Hello there, Mr. Chan here for Algebra 1. We're about to do a topic 7.1 to 7.3 review. Please grab your review worksheets and turn to page 307. Let's get started here. We have some vocabulary to go over here. Number 2. The blank states that polynomials are closed under addition or subtraction because the result of those operations is another polynomial. The answer is closure property. Number 3, you'll learn about in another section, but you'll get this result later on in the first half of this topic. A blank results when a binomial is squared. So if you have a plus b squared, you'll get a perfect square trinomial. I'll mention that later on. Number 4, a blank is a real number, a variable, or a product of a real number and one of more variables with whole number exponents. This is just a monomial. Number 5, the product of two binomials in the form of a plus b times a minus b is a squared minus b squared. That thing that we get right there, a squared minus b squared, has a name. It's called a difference of perfect squares. And finally, the blank is an expression in which the terms are written in descending order according to their degree. The answer here is the standard form of a polynomial. All right, that takes care of the vocabulary. This review is short. It's only 3 sections. We are going to do 7.1, 7.2, 7.3. 7.1 has some vocabulary. It's about adding, subtracting polynomials. The key here is to add and subtract polynomials with like terms. That's the key. They have to have the same number of variables and powers of those variables. All right, polynomials defined right here. It's a monomial or sum of difference of 2 or more monomials. Those are called terms. The degree of a polynomial is mentioned as well. It's the greatest degree of any term of the polynomial. So you pick the one that has the highest power amongst the many terms inside the polynomial. And finally, the standard form of a polynomial we just mentioned a few moments ago with the vocabulary. It's when you put the terms of the polynomial in descending order, meaning going down by degree, which is also known as the power. Here's a great example involving the difference, which means subtraction. Keep in mind when you're subtracting polynomials, you want to apply or distribute the minus sign to the back half of the polynomial. In this case, that's what happens when they apply a negative sign, and that's why we have a negative 2x squared minus 8. And then from there, they went ahead and combined like terms. And they got an answer right there, 3x squared plus 3x minus 13. Take a look at that when you get a chance. Number 7, 8, and 9, I'm a little bit concerned about these problems right here. We're going to give it a name. What kind of a name are these monomials? Number 7, they're calling linear. I'm questioning that. I don't like that answer at all. So I'm just going to say, you can ignore number 7. Don't worry about that right now. Number 8, though, is a number by itself without any variables. This is called a constant, so that's okay. Number 9, they went ahead and added up all the powers here. We have a 2 and a divisible 1 for a y variable. That's power 3. A monomial with a power 3 is called a cubic function. Okay. All right, number 10, 11, 12, we have some addition and subtraction. Number 10, we have addition between two polynomials. We want to look and combine like terms. Pretend the parentheses aren't even there. It's not even necessary. They're just not there. Let's look at the x's. First, we have 5x and 2x. I'm going to add those together. It gives me 2x plus 5x is 7x. Nice. And then we have, of course, -1 and plus -3. That gives me -4. Not too bad, huh? 7x minus 4. Number 11. We're doing subtraction, so you got to be a little more careful here. We're going to distribute that minus sign to the back half of this parentheses. So I'm going to rewrite the problem. First polynomial stays the same. Second polynomial preceded by a minus sign becomes minus 3x squared minus 8x, and negative is positive 4. From here, I'm going to go ahead and combine like terms here. Let's see what I get here. Let's see. We have, of course, 2x squared and -3x squared. That's going to be a -1x squared. Great. And we have some x's to combine together. Let's deal with that. We have -4x and -12x. 8x, that gives me -12x. I was thinking of the answer in my head. And then finally, the constant by itself. We have -1 plus 4 will give me plus 3. All right. Any questions? That was not too bad. We'll just combine like terms. All right, number 12. Addition problem, yay. We just pretend the parentheses aren't there. Let's look for some b to the 4th powers. Let's see. Oh, there's one right there. Oh, there's one way in the back. So 5 of those plus 3 of those is 8 of those. B to the 4th, right? We always change the coefficient, but not the variable itself, the power. Leave that alone. B squares are next. There's only one b square, so I'm going to kind of bring that over. Oh, wait, there's another one right here. Kind of missed that one. Whoops. So 3 of those b squares plus 5 of those b squares will give me 8 of those b squares. And then finally, I have my constant. That is just -2. And -4 added together will be -6. And there's your answer. Yay. All right, moving on to number 13. What is missing in the term of the equation that will make this equation true? It looks like we're missing a variable. I noticed that in this spot, it probably should combine with the 3x to give me 8x. So that's what's happening there. Something plus 3x will give me 8x. That definitely is 5x. That was pretty easy. Yay. Any questions about the first section? We're just going to skip number 14. Let's move on to the next section, okay? 7-2. Here we go. Woohoo! Oh, after adding, subtracting, we're going to be doing multiplication. We're going to apply the distributive property everywhere. Some people might say, hey, we're going to apply, depending if it's a binomial times a binomial, we'll use something called FOIL. First outers, inners last. First terms, outer terms, inner terms, and last terms. It's not a big deal. It's just a way of saying distributive property, but with some fancy thing with the binomial times a binomial. So you can see in this example, they do have a binomial times a binomial, and they do something called FOIL that we say, and they just basically do that. You can multiply in a box if you wanted to. And I'll show you that right here. Some kids prefer that. When you're putting into a box, you're basically finding areas of those rectangles. All right. Let's try some over here off to the right. Number 15. We're asked to multiply a couple of binomials. I'm going to apply the distributive property for number 15. You can use a box if you like. No one's stopping you. No big deal. So number 15, let's go and FOIL. Here we go. X times x is x squared. That's the first terms. Nice. Outer terms. Whoa. X times -5 is -5x. Those are outer terms. Inner terms are next. 7 times x is plus 7x. And last terms on the end, 7 times -5 is -35. Now, we multiplied 4 pairs of things. And what that means is that sometimes they can be combined together. In our case here, the inner and the outer terms can be combined together. They're like terms. -5 and +7 can be combined together. That will give me, final answer, x squared. -5 plus 7 is plus 2x. And there's your answer. Yay. For number 15. Great. Number 16. Let's do that one. Here we go. First terms. 2x times 3x is 6x squared. Watch out for that variable. We're now multiplying. Not to be confused with the last section where we're adding, subtracting. Subtracting, you don't change the powers, but multiplying you do. Outer terms are next. 2x times 1 is plus 2x. Great. Inner terms are next. -5 times 3x is -15x. Great. And last terms are last. -5 times 1 is -5. Again, our inner and the outer terms can be combined together. Our final answer is 6x squared minus 13x minus 5. Yay. Not too bad, right? All right. Number 17 and 18, they say use a table. They're basically saying a box. Let's do number 17 in a box then. All right, here we go. Number 17, it's a 2x2 box. 4x minus 3y along one side and 5x plus y along the top edge. Let's go ahead and FOIL this. 4x times 5x is 20x squared. Great. Outer terms, 4x times y is 4xy. Interesting. Inner terms are next. -3y times 5x is -15xy. And then last terms we have -3y times y is -3y squared. The diagonal, in this case the outer and the inner terms, will combine together. 4 plus -15 will give me -11? Yeah, it will be. So let's put that answer down right now. Final answer, 20x squared minus 11xy minus 3y squared is the answer. Yay. Number 18 is next. Write that down. Put it in a table. This time, though, the table is bigger. It's a 2x3 table. X plus 4 along one edge, and x squared minus 3x minus 1 along the other edge. All right, here we go. I'm going to do my first row here, product. X times everything in the first row, the top edge there is x cubed minus 3x squared minus x. Second row product. Here we go. That gives me 4x squared minus 12x minus 4. Now, out of these 6, 2 pairs of terms can be combined together. The x squares can be combined together, and the x's can be combined together, giving me this answer right here. X to the third. Let's check the x squares out. 4 minus 3 is 1. Nice. How about -1 and -12 is -13x and -4, the constant that didn't get affected at the end. There's your answer. Yay. Number 19 is next. Swimming along pretty fast here. Wow, this is turning out to be a pretty fast review. Yay. We did one of these in the last section, finding out what the missing product is. In this case, it's kind of interesting. When we FOIL, the binomial times the binomial, some items are missing. So I'm looking at the first terms here, the FOIL. That'll give me x squared. So right there in red, something times x will give me x squared, and that's x. Ding, 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 there's one answer. That has to be the only possibility. And the last terms is kind of interesting in blue, 24. 3 times what will give you that? That has to be an 8. So there you are, ladies and gentlemen, the x and the 8. Now, just to make a quick check here, did you guys notice that the outer and the inner terms keep adding up to the middle term, 11? Does 3 plus 8 equal to 11? The answer is yes. So start thinking about that kind of a mental math there. All right, number 20 is last for this section, where the volume of a cube is calculated by multiplying the length, width, and height. You may know this from middle school. The formula for the volume of a cube, in this case, is length times width times height, but it happens to be an actual cube, so they're actually all the same lengths. So it's basically length times length times length. They happen to be 3x minus 1 as it's labeled in the picture. We're going to multiply all 3 binomials here. Takes a little time, so let's try it. Number 20. We're going to take a side of the cube and multiply by itself 3 times. Okay? So I'll just concentrate on 2 of them at a time. 3x times 3x is 9x squared. Outer terms are next. 3x times -1. Nice. Inner terms. Oh, same product. Yay. And last term, -1 times -1, be careful here, is +1. Clean those up. And I'll get a polynomial of 9x squared minus 6x right there when we combine the middle 2 terms, plus 1. Now I'm going to bring this down for my third side. Wow. This is going to require a lot of distributed property. I think I'm going to do a box or a table, they call it. Let's do it. 3x minus 1, and then the answer I just got a moment ago, 9x squared minus 6x plus 1. I'm going to go ahead and FOIL this, superfoil. Ooh, backwards. Ooh, backwards. So 3x times the first row is, excuse me, 27x cubed minus 18x squared plus 3x, and then the back half. Ooh, the -1 changes all the signs. Changes all the signs. Combine like terms. 2 of the pairs are going to be combined together right there and right there. Those are like terms, yay. Final answer for number 20 is 27x to the third in descending order minus, let's see, -18 minus 9 is -27x squared. 3 plus 6 is 9x, and minus 1. Wow. That was pretty crazy. Any questions about number 20? I think we're ready for the last section. Aren't you glad we split this up into 2 tests? All right. So sometimes when you multiply, you get special cases. They include something called difference of squares. When you multiply a positive and a negative binomial, you'll get this answer right there, a squared minus b squared. That's called the difference of perfect squares. Another type of a special pattern is what happens when you take a plus b and square it. When you do that, you get A plus B times itself. And when you multiply that, you get this thing right here. Ooh. This is called a perfect square trinomial, which won't be mentioned until later on. So that right there has a name, and I'll star it. You'll learn it in the other section. It's called a perfect square trinomial. I just want to bring it up now, so you won't be surprised. So we have these patterns that I've boxed out. Let me double emphasize it. Right there and right there. Those are patterns. All right. So the example they gave us is a product of a sum and difference. And the pattern is right here. A squared minus B squared. I just threw the A's and the B's in there and simplified. All right, let's try those patterns over here off to the side here with numbers 21 through 26 and see what happens, okay? Okay, so 21. Ooh, I have B plus 12 times itself. Oh, that is a product of a binomial, okay? That's the square of a binomial. So for number 21, up here, give myself some space. The pattern is A squared plus 2AB plus B squared. Now, if you don't know these patterns, you can actually just FOIL it, and it's not a big deal to memorize these patterns, but it's kind of cool to use them. So, excuse me, I got that from here, the pattern itself. All right. So what is A and what is B? And unfortunately for number 21, they used letter B there, which can be a little confusing. I apologize. But that B plus 12, that B is technically A for the pattern, and that 12 is technically B for the pattern. So I'm going to put those numbers into up here. This is B, B, 12. I know, sorry about that. It's kind of a bad choice of problems there. Let's clean that up, and we'll be done with number 21. This becomes B squared. And now the middle part, you got to clean that up. 2 times B times 12 is plus 24B. And now in the end, 12 squared is 144. And it's not the end of the world if you don't memorize the pattern, but you'll get that anyway if you were to FOIL it over here on the left. You'll get the same answer. It's not the end of the world. 22. Same problem, different numbers. All right. Same pattern. B squared, I'm sorry, A squared plus 2AB plus B squared. So in my problem, 4x is your A, 1 is your B. Okay, put those numbers in, 4x, 4x. I'm using this pattern, and I'll write it up here. A squared plus 2AB plus B squared. So you can see what I'm putting into those empty parentheses, okay? And there's your 1 and your 1, and that's it. You clean it up. Patterns are cool, not the end of the world if you don't memorize them. Clean up the first half. 4x times 4x is 16x squared. The middle there, 2 times 4x is 8x. And then finally, 1 is 1 when you square it. And there it is. Ooh, 23 and 24 are a product of a sum and difference. That uses a different pattern, and that pattern for those guys is A squared minus B squared. Yay, difference of squares. Those are my favorite pattern. That's awesome. So here's 23. A squared minus B squared. Okay, that's the pattern. Looking at 23, A is 6x. I'm not doing 25, by the way. B is 9. Let's just put those numbers in. 6x and 9, and that's it. That's easy. That's all you have to do. Clean that up, clean up the pattern. 6x squared is 36x squared. 9 squared is 81. Again, if you were to put that in a box, you'll get that answer if you did it manually without a pattern, okay? 24 is next. Ooh, a squared minus b squared, because it's a difference of squares. You guys see the minus plus thing right there? That's how you know. Look at the signs, by the way. I may have skipped that. Sorry about that. So 21, our signs were positive, positive. You use the first pattern. 23 and 24 are negative, positive. That's when you use this other pattern, okay? That's what I'm looking at. Sorry about that if I didn't mention that early on for the review there. For 24, A is 3x. B is 4y. Let's put those in the pattern, 3x and 4y, and clean it up. Easy. 3x squared is 3x times 3x is 9x squared. 4y squared is 4y times 4y is minus 16y squared. Woohoo! Not too bad. Yay. I'm skipping 25. Let's do 26. 26 looks kind of weird, doesn't it? I have to expand and FOIL here and see what happens. Okay. This is basically 3a minus 5b times itself. Now, this book doesn't mention subtraction. When you look at this, a is 3a, but b is a negative 5b, because both of them are negatives, okay? So you got to be careful there. So the pattern is like 21 and 22. It's a squared, in this case, plus 2ab plus b squared. Okay, let's put the numbers in. 3a, and negative 5b. That's important now. That's negative sign, okay? Okay, let's clean that up. 3a squared is 9a squared. In the middle part, be careful here. 2 times 3 is 6 times negative 5 is negative 30ab. And then the back half, negative 5b squared is positive 25b squared. And ladies and gentlemen, I'm actually going to skip the last one and call that my final problem for, oh wait, yeah, that's 26. I misspoke there. That's 26, yay. My final will be 27. I misspoke a little bit. I won't be doing 28. So 27 is actually kind of easy. We're looking for what m is. M is the first term coefficient multiplied together. Oh, that's easy. 5 times 5, that's 25. No way. That was pretty fast. All right. Well, thank you for hanging in there. We just made it under 30 minutes. How great is that? Thank you very much. Have a good day. Bye-bye.